This is what I was wearing in my speaker picture. It's too small to really see the story in there, but my tagline was, I'm driving the monster truck of data, YAWS, to do dynamic browsing, dynamic benchmarking in the browser. So this is a way to take YAWS, run it embedded as an included application inside your Erlang application, and then use JavaScript and modern tools along with YAWS. I think there's been a big discussion recently about all the new Mochi, Misultin, Cowboy, Chicago Boss, all those. They get a lot of rep. YAWS, nobody really talks about. It used to be that you couldn't embed it, now you can. So this shows a way that you can embed it. And if you want to follow along on the code, I've got two projects on my DualMark GitHub. DualMark's sort of my official products. I have a separate GitHub that I do other personal development in. But DK YAWS is a wrapper around YAWS that does all the embedding for you. YAWS is a web server that's similar to Apache in its origins, and it's been around for more than a decade. So it's stable, solid. It's got a lot of features that have been added for performance reasons. And it now has modern things like WebSockets and so on. But I'm showing here just using standard old YAWS in a PHP-like manner, running with JavaScript. So DK YAWS will let you embed into your own application just by changing a couple config variables if you use rebar and not have to do anything else, and now you've got YAWS in your application. Bubba is the application where I'm demonstrating the capabilities of YAWS inside an Erlang application. And that's showing, measuring performance of Erlang internals and displaying the results of the benchmarks graphically. And for that I use D3. D3 is a really great tool for graphically representing data. So the goal is to run a benchmark server, collect the timing results, and animate the data graphically. The technique would also apply to any other data set though. So if you've got dynamic data and you want to feed it into a browser that a user can interact with and display that information, then this is a great example of how you would go about doing that. Here's sort of what my benchmarking tool looks like. I've got a form over here where you choose what you want to benchmark, and then you get your graphical results. What I'm showing here is running a benchmark which sends back results using JSON as a set, and then I graph that set. But if I were to have a long-running benchmark, I could switch to using WebSockets and stream back the data and have the graphics changing dynamically over the course of hours or whatever. The problem with the approach I'm using is that it'll time out in the browser if it's a big test, and so you would want to switch to a streaming approach. But by embedding YAWS, you have every option that YAWS has available. So the browser is for the user to interact, start the benchmarking, and to view the results. I use YAWS to parse what the user is requesting, and then the application itself is the Erlang server that's going to run the benchmarks that are accessible through the form. And D3 has not just graphics tools, but it also has built-in tools for dealing with arrays, JSON requests, different things like that that you would want to do in an application. So it's a simple call with D3 to make a JSON request to the YAWS server and get the results back and bind it to the graph. But what it does let you do is a very generic approach to embedding graphics so that you can change the visualization without affecting any of the other components in this system. So I try to separate everything into pieces that are independent. The interaction with the user is happening with the HTML5 and the D3 representations in the browser. And so you can style that independently of anything else in the system. And that's one of the big features of D3 is that it's declarative rather than procedural. So it came from ProtoViz, which was developed, Mike Bostock at Stanford, I think it was, developed ProtoViz. And that was a language sort of like processing that let you display graphics, but you would call functions to say draw a pie chart, animate this part of it. And anytime a new feature was added to the browser, then you would have to add to that functional language of graphical symbols. So he abandoned ProtoViz and moved to D3, which is data-driven documents. And the idea is that data is coming in or is going away, and that should be reflected directly on the screen, but it should be styled similarly to the rest of the application. And so it uses CSS style and SVG or HTML components and lets you apply the style using style sheets or change the visualization by changing the SVG components that you're embedding. But it's done in a declarative, mapping the data directly to DOM objects. On the Erlang side, we've got a YAWS, which is a complete application standalone by itself, but I'm running it here as an included application embedded inside my application. And then the benchmark server, which is a little test program, but you would install, let's say you have a production system that you want to benchmark in its environment as it runs, then your server code would be here and it would include YAWS, and then the benchmark functions that you would want to invoke get exposed out through the HTML so that they're called via YAWS. Here's sort of the message sequence that happens. You pull up the index.yaws file, which I was saying I'm using the PHP style approach, embedded Erlang in the HTML page. YAWS has a feature to essentially write PHP using Erlang style, and that turns into an index.html, which has the form that the user interacts with. And that gets sent back to the browser, and then they fill out the form and submit it, which goes to D3. That's the JavaScript that's embedded in the page. And D3 then makes a JSON call to the YAWS server, which runs the benchmark, sends back the results as JSON, and then D3 can display the chart in the browser. Now the reason I want to do this style is because if we go back, not only do I want to separate style from the server, but I may also want to separate execution from the visualization. So if I'm running an EC2 server or something, that may be off somewhere else, and I need to have a remote protocol between the browser where the user is viewing it. So I wanted to stick with JSON as sort of a standard way of doing that. But D3 makes it really simple to do that, so I'll show that in some of the code. So the code I'll be showing is a mixture of HTML and JavaScript and Erlang. But if you follow along on GitHub, you can see all the code. So the first step is embedding YAWS, and that's why I say DK YAWS is a full rebar application that's open source up on GitHub. And if you just list that as an included application in your application, that's all you have to do. You now have YAWS running in your application. You can do any YAWS features directly. So inside the app source of DK YAWS, I've got, and this doesn't show very well with the resolution reduction here. In my application description that's used by Erlang for the app, but also in the rebar build, in the included applications, I've got here crypto, SSL, inets, and YAWS. Now normally, everybody that does open source makes applications. They assume their application is the top level application. People want to use it, we'll just run it, and then they'll call to it. Nobody really ever seems, I haven't seen one yet, where they use an included application. What included application does is says, your root supervisor calls the root supervisor of the other application. And so now that supervisor is supervised by you. Whereas if you list it in the application section, you're both at the top level. If YAWS goes down and your application's dependent on it, then it's not going to work, and you won't know it's down. If you make YAWS a permanent application and YAWS goes down, the whole node goes down now because it's a required application and it's down. And you probably don't want either of those. Sometimes you do want the whole node to go down. If like Redis goes down and you don't have anything, then maybe you want the node to go down. But there's more graceful ways for that to happen than just the application master killing your node. So what I did here was put it as an included application. And then in the supervisor initialization in DK-YAWS server, I use the snippet of code that YAWS has for embedding a YAWS server in your own application. And YAWS is written closer to OTP than a lot of the other like mochiweb servers, but it's not exactly done with a root supervisor. And so you call a function and it hands back a collection of supervisors that the root supervisor should launch. And so then your root supervisor has to run through that list and launch all of them. And that's the snippet of code that they give in their examples in their documentation. And so I've grabbed that code and put it into my application, DK-YAWS, so that if anybody else wants to embed it, they don't have to write that piece again. They just include DK-YAWS and then you're done. But you can see here it's getting the configuration information, and I pull it actually from the command line or the config file, or I default to what YAWS has as its application defaults. And so then if you include it, you can set those parameters in yours or just leave them to the defaults. Or you can do it on the command line and not even having to change your config file. And then here's where it does a list comprehension over the supervisors that are returned by YAWS. The last step is putting your config parameters. And so I added parameters for the default port, default IP, and the doc root. Those are really the only parameters that are necessary to get started. Over time, I hope if people use DK-YAWS and they contribute back to it, there'll be more options that become reasonable defaults as you use some of the features of YAWS that require other configuration parameters. But if you're okay with these, localhost 8000 and whatever version of YAWS you're running, or DK-YAWS, then it'll just run. But in your VMARGs, if you're using Rebar, which I recommend, now, before you used to hand roll the apps, but now Rebar makes it so much easier. If you follow the Rebar standard and use something like this, it's a one-liner in the Rebar config to include the dependency, and it's a one-liner in the app source to say include DK-YAWS, and now YAWS is running. So D3, if you want to see more about D3, Mike Bostock is the author. He now works for Square, the credit card iPhone slide guys. They have a lot of data. They monitor in real time a lot of information. They're doing some really cool visualizations. The D3 is his generalized tool for doing charts and graphs, but he also uses it for geographic stuff. He's got Albers projections and all kinds of things built into it, just unbelievable stuff. And Voronoi maps and just a lot of visualizations. They also have a couple new things. They changed the name of it. It was called Tessellate or Tessellation or something recently for handling millions of data points in real time in JavaScript in the browser so that you can filter and display just the parts you want. So I like this approach over the procedural approaches because you don't have to change your code. It's all loosely coupled in the data and in the HTML or the CSS style sheets. And they're making it possible to handle lots and lots of data in the browser. But the declarative mapping is a big important thing. It also does the animations. Those are using CSS transforms. So It could translate and rotate and do all the kind of 3D things. But if you have a graph that's a line graph and you switch to a bar graph, you can do an animation that actually animates that transition from one type of graph to another graph. And I haven't gotten there yet in my demos. Hopefully Saturday I'll be hacking. What I want to do is run a benchmark, run 2, 3, 4 benchmarks, and it does a bar chart. And then if I do enough of them, it decides to switch to a line graph or scatter plot or some other variant, and just does it automatically based on how I'm using the tool. And he recently posted, if you go to this Bostock's chart, he posted a way to declare charts like pie graphs and bar charts and so forth, and embed them so that it's an object in JavaScript that you can just set the width and height. This is another, like if you create a pie chart and it's 300 by 400 and then you want to change it, you may have to erase it, call the function again with different init arguments, something like that. What he does, he uses a method called function chaining, so that when you create an object, it returns that object, and then you can set the height on it, and that returns the object, and now you can set the width on it, and you can chain all those together in one command. And by using his approach to embedding the chart, you could easily switch from one chart to another or resize it dynamically using transforms, and that's all declarative in the HTML. So basically we've got a form layout in the browser for the user to interact with, then the JSON connection to Erlang, and then YAWS executing the code. And in the YAWS file, it's hard to read this, there's a form. In my case, I've got a pull down, and I'm offering you options to do iterations. So which is faster, calling a function that loops with tail recursion, or calling a list comprehension that iterates over the list, or calling map? I wanted to compare things like that and see graphically how they compare. So I have several options, like doing internal operators, doing iterations, doing function calls. And you select in your form, fill out the form, and then when you hit submit, on click, I do a D3 submit, which is this JavaScript function right here. It's on the next slide, is the D3 submit function, but it uses the function make URL, which collects all the elements from the form that the user has filled out and creates the URL that's going to be used to retrieve the JSON. So the purpose of forms in HTML is to provide an interface for a user to build a REST endpoint. And so essentially this is exposing exactly that behavior, that the user is choosing what they want to see, and I'm constructing a REST endpoint that goes and fetches that resource. Now it turns out it's returning JSON and displaying it in a certain way, but here's the D3 submit. And here's one of the features of D3 that's really great. I mean, even if you don't use the graphical display, you could call d3.json, give it a URL, which is the make URL function, which constructed it from the user's input. And then you give it a JavaScript function that does whatever you want with all the JSON results. The JSON is handed back to you as an array of JavaScript objects. You don't have to deal with it, mess with it, or know anything about it. You just iterate over the JSON object. And so in here, I pull out the data that I get back and push it onto a list that's being used to display the graph, pulling out just the attributes of the JSON that I'm interested in. And here's where I do the chart. So I create a chart object that's a Bubba time series chart. I have an example of one in the code there. And then it sets some functions on there that access the X and Y parameters that are going to be graphed. And this is the flexibility that D3 gives you, is that the X function So when you're accessing a point in the graph, I have a data element out of 100 data elements. What is the X value and the Y value that I'm going to use to chart it with? Those are actually functions closures that are attached to the data object. So now all I have to do is give you an array of data objects, and those functions can be swapped out at will in the JavaScript code without touching any of the rest of the code. So that's why I say it's declarative. I request data, and the data is bound to functions at the time it's displayed, and I can change that binding to display them in a different way. And I can do that dynamically by another JavaScript function that swaps out those functions. So it's very powerful. And then at the end, there was just the graph area. I just call that function to plot everything. So here's the YAWS. How does YAWS? Here I'm doing like a PHP, the URL/URL instead of the question mark PHP or however they do it. And there's a function, this is a YAWS function, out A. It takes whatever parameters were passed in on the URL and lets me get at them and parse apart the path and look at the parameters and everything. And so I just use the YAWS functions to parse the query. And I pull out the elements that I'm interested in, and I pass them to this bench function. And bench is what's calling my Bubba server, and it passes in the properties that are needed for my benchmark to run. So if you have an application that already exists and you want to test some function points in that application, you would have this bridge that goes from the REST URL to the functions that you want to invoke. You may have to put in a little piece of code in your application that receives those and then sends it out to the right piece, especially if you have a distributed system and you have one entry point. Behind the entry point, you're going to have to get to the code. So that's pretty much everything and how it's constructed. If I go back just to remind you, all these elements are independent. So each of these elements you can swap out and replace and do independently. And I don't know how this is going to display. Oh, it's not too bad. It's not too bad. So here's my form on this side. And over on this side, I've got my graph, which I can generate. And I just want to run, like right now. So I set up my menu with, there's a data access option where I can test things like list nth versus list head versus accessing a binary using binary pattern matching or using the binary module or using tuples. So right now it's saying I'm going to test list access by generating a list of random elements and timing the execution of list nth removing from the head. So I create a list of size 100 with random elements, and I think I just stick in integers. And the nth position is anywhere from 1 to 1,000 randomly. So sometimes it'll take the 7th element, the 25th element, and if I run that benchmark 100 times, well, you see, it got dominated by some garbage collection or something right there. Now we can see that 100 cases ran, and there was some variance in the cases as it warmed up or whatever caused the low points over there. But right here I'm plotting, I don't have my scales worked out well. D3 takes care of your scales. You can do linear, exponential, whatever. You just swap a function declaratively and it'll plot them. I'm just not labeling. This is actually nanoseconds, I think. So doing list nth is on the order of 10 nanoseconds. When I do head for a similar thing, I get my garbage collection again. Similar, it's 6 nanoseconds. Native binary. Here I'm doing binary access by generating a random binary and timing the execution of skipping over a random number of elements and pulling out one byte. And so I'm using, again, the binary size is 100 integer, 100 bytes, and 1,000 accesses into it. Garbage collection. So here now I'm seeing 200 nanoseconds. So, you know, a lot of people say, geez, strings are lists and lists are a pain in the ass. And, yeah. But it's 2 orders of magnitude faster, or one and a half order of magnitude faster to access a list than it is to index into a binary. Even though you get that compression, the VM is optimized to work with lists. So if you got like 50 elements, it's probably way faster to do it in a list. Now using the binary module as opposed to the native, get my garbage collection. So this looks like binary at is running faster than native binary on my machine, on my circumstance. You know, it's all relative. I was looking for relative performance. I want to do a bar graph that runs all of these and shows the spread, or does a scatter plot and shows how they compare. Tuples actually are quite fast when the garbage collector doesn't run. Yeah. Yeah, I know. Something's up there. But anyway, so that gives you an idea. I also had operators so I could look at plus, minus, and less than and greater than. I was just kind of enumerating through different things and putting them in the form. Iteration with function call versus module colon function versus list comprehension, a list that's tail recursively called with functions, binary comprehension, and binary function loop. I thought, you know, there's a spread of things. You'd like to graph that and see how they compare to each other. And then, let's see, I've got the wrong menu here. And then I ran some tests with spawning processes and messaging. And right now this isn't working properly for me, so that's Saturday hacking. But on messaging, when I did run it, there was receive and send messages. Originally, I would create a process, generate, you know, 1 million messages, and then send them to another process and see how long it took. And I thought, you know, how much difference can there be between sending a message and receiving a message? It's basically the same thing. It turns out it's 40 times slower to send a message than it is to receive it. Because when you send it, you're going from one context to another context, and it has to be, you have to do a context switch, you have to copy, you have to potentially even lock, you know, internally in the kernel, and then put the information there, and then get back to the other context. When you receive it, you're in the same context and you're grabbing something that you don't need to lock or do anything. So I had observed before that if you have a gen server and it gets overrun, gen server 2 came about because of this. You know, it gets a really long message queue and you can't catch up. You like try and chunk through it, and you can't catch up. But if you collect 100 items off of the list of messages and then do a list comprehension across them and then get the next 100 and do a list comprehension, you actually can chew through it much faster. And part of it is if sending is 40 times slower, then you can process 40 receives before you get another send. And that led me to think that if I have a sender that's sending that much, I could put a process in between whose only job is to pull 40 things off and put it in an array, and then send the array to the next process that actually processes them. And then it only has to do one receive, one receive, one receive. And it can keep up a lot faster that way. And that's actually a trick rather than using something like jobs to control and throttle and do all this stuff. If you can cascade, at every point, you do some analysis and reduce the number of messages you pass on to the next step in the pipeline. And even if you do it by collecting them into a bag and handing the bushel over, you can speed up the pipeline and get concurrency because you're working at multiple levels at the same time and get improved throughput at the far end of the pipeline. And you don't have to control what's coming into you. It just sort of happens naturally. And if things start to slow down, just insert more processes in between. Slow down the pipeline length, but speed up the bulk size of it. And at some point, you can spread out the receiver and replicate what's chewing up the messages, so that if writers are overwriting you, create more readers dynamically, and then you'll catch up, and then you can get rid of those readers dynamically too. So those sorts of things were things I was trying to discover by benchmarking the primitives of Erlang and having a comparative way to say, all right, I've got an algorithm, it has this behavior, I think this replacement is faster. Let me compare them head to head in the same environment, running under the same circumstances, maybe on a remote machine, and still be able to view it and have it visually available. Any questions?
Is it sends were 40 times slower?
Yeah, that's what I was seeing. But you know, it's on a laptop. And I was doing it locally, not across the network. You know, but most of the open source applications you see are running locally on one machine with multiple processes, and most of the bottlenecks and problems people complain about being bogged down is related to too many processes or too many messages or too many spawns, you know. So just understanding that I have a system, it's running fine, and then all of a sudden it gets bogged down, being able to see where that happens and how that happens. This is a tool that might give you another way to get a peek inside a running system. There's a lot of ways to do it, and some of them are buried in OTP manuals, and people have a hard time finding them. But this is a way to give you a hook to do quick and dirty little things with code you understand that you can reach in and fiddle with and see. And the biggest thing that I was hoping eventually to get to is, I've got an open source project, somebody sends me a pull request and says, hey, this is a much better way of doing your queue. Yeah, prove it. Like, here's the code, you run it, I'll run a browser against your thing and see what it looks like. If I can convince myself, or I can prove it myself as the person that's going to merge in the pull, I can run it with my code and then swap the one function and run it again and see how it performs. Or write a little adapter so I can have both of them running at the same time.
And so how involved is it to, like if I wanted to test a file system where people could register for whatever service, how difficult would it be to pull this down, set up a node, and then add the function that is test user registration? So
if you look on GitHub, really it's just bench server.url is one file. And it has two approaches. One is related to messages and one is related to looping. And basically, how many times do you want to iterate and how many things do you want to deal with? And then in messaging, there's a third parameter. So it's essentially two function signatures. And then I created modules for each of the pull-down menu items. So basically, you would look at the bench server.url and just make a call out to your code from there. Now, what I want to do is get to the point where it's a behavior, because I'm trying to build this up and find out how many signatures are the same of this type and of that type. Then I can build a behavior, and then you can just mix in a behavior and have it as an included app, and then it would just work. So I'm like 2/3 of the way there. But right now, it's you look at one module and look at an example module, and it should be straightforward what to do. So if anybody wants to hack on it or look at it or get an explanation Saturday, you know, or even catch me, that's why I wore the yellow shirt. you can find me anywhere. So, yeah.
Isn't there any risk that by using included application with YAWS, you're making it that it's now impossible for me if I have an application using YAWS to benchmark it? Because you're including it in a way that's the only dependency available is within your app.
Right. So if you don't want to include it, you can just move it from that included applications line to the applications line and restart.
And then I need to fork it to be able to do it at that point.
Because you're changing something before it's built, right? It's the app.source.
Right. It's doable with minimal damage to the
Right. Yeah, the reason why is because if you don't have it as an included app, then you assume it's launched by somebody else external to you, either before or after. So there's no coordination. That's the other reason why I have this pet peeve about not having an included application. There is a mechanism in OTP to coordinate multiple applications, and that's called start phases.
And releases.
And I don't see start phases used either in open source applications.
I do prefer included application to start phases.
Yeah. So, but with start phases, if I need that thing running, but I need to make sure it's running before my piece starts running, then I can have a start phase that starts it and then my phase. And we had a discussion earlier about start phases and included applications, that if an included application has start phases, now the thing that includes it has to know about those. But it doesn't have to necessarily know anything about them and add anything to them. It can add new phases and just start those phases first and then do its phases in between or after. So including just adds more things. It may make things a little more complicated, but they're additive in layers, not in intersection. Yeah.
Just a small question about included applications. How does it affect the application environment?
So
Usually you get, when you call get and get it from the application that you started permanently
right.
in that environment.
Right. So the question is, on included applications, how does that affect the environment parameters or the application parameters?
Yeah, but it decides that based on the group leader.
Right. Well, an application is a single entity that the application master knows about. And if you have two applications, then the application master knows about two applications. And within an application, if you ask for the application configuration parameter, you get the one that's specified for your application that was loaded with your application. So there's no way for me to get the configuration information for another application directly, intentionally, the way OTP expects it. If I make it included, I'm not including the application. The way it's specified is that application should just be start and stop and start phases. And there's a root supervisor that should be called in start. And really, you should try not to do anything else in start. That root supervisor is instead called by my supervisor. So the application doesn't exist. The root supervisor does exist. When it looks up the application tree, it gets to my application, not to the original application. So I can override any parameter that the original application specified in my application's configuration arguments. And that's why I said, if you want to change the port number or the IP address or the doc route, you just change it in your application or on the command line, and that will be the context for the application that's executing, not the compile static context. So the real difference between applications and included applications is, what impact do you want on the VM if that application goes down? Do you have a way to control and restart? If you don't, then there's no point in putting it in yours. It's just going to take you down anyway. But if you do want that to take you down but not take down the VM, then you should make it an included application. If you want that to take down the whole VM, don't make it an included application. It's really the... Yeah, you could do temporary or not, yeah. But when I think about architecting with OTP, the first thing I think about is, how do I want it to crash? Everybody says, crash immediately or fail fast or whatever. I forget what the phrase is that they use. Crash early, crash often. You know, they say it a lot of different ways. But there's an implied philosophy behind that, that's crash immediately as soon as you know that it's a safe place to crash. You don't want like your core key process that has every user account in memory for speed and performance to crash because of one bad thing went wrong. Because now it's an hour restart to read it from all the remote databases and everything. And if that's happening, I mean, when you're developing, you want it to crash immediately so you can find the bug. But once you deploy it, you only want it to crash to protect the system from going down. So you isolate things in the supervisor hierarchy and make them crash in a fashion that they'll restart a few times and then they won't come back up, because if they come back up, they're going to just propagate up the supervisor tree and take everything down. So I think early about where is it safe to crash and where do I really not want it to crash. like an ETS table. A lot of people use an ETS table to cache data so that they can get it easily. If that process crashes and you lose that ETS table, nobody has the information. So you say, okay, I need this feature. I'm going to use an ETS table, but I'm going to make it inheritable. And I'm going to start it up with a process that's an ETS supervisor, and it does nothing else but set up the ETS table and hand it off to a worker. And then if that worker dies, I get the ETS table back, and all I do is assign it to a different worker. And my whole job is to make sure I always stay up. I should never crash, so that I don't lose that ETS table. Because as soon as I lose that ETS table, now I have all kinds of contingencies that I have to worry about. And people always say, well, if I lose that, I got bigger problems. Don't start out with that line of thinking. Start out with a line of thinking that I'm going to contain every big problem into some small area, and now it's a small problem and I don't have to worry about it. So that's the part of applications and included applications that never really gets discussed, and why people don't use it. They're just not aware that there's a trade-off there that's being made. And it's easier if you've come from Pascal or Ruby or some language that likes to control the whole environment and be the master, then it's easy to say, well, my application's running and we'll figure out a way to get yours to run, but mine's the one that's in charge. And with OTP, you really need to say, I'm building a system that's engineered to be a cooperative collection of components, and every component should be embeddable in some other system. And it should be isolated so that I can test it and isolate it from crashes. And if you start out with that line of thinking, then you get much more reuse out of your software and much more control over a production system.
One final question.
Yep.
Where'd you get your hat?
This was from Zazzle. And I actually asked Clacky to turn the GIF into an EPS so that I could print it bigger. But it turned out the GIF actually sized up, so yeah. So if anybody can see Clacky in the next week, I'll give him the hat.
Thank you very much.